I guess we'll start now. Welcome to the third academic seminar. In order to get the 10 automatic PEP hours, make sure to attend the next seminar, complete the feedback form after the last seminar, and fill out the sign-up form if you haven't already. Please turn on your cameras to make Aaron feel more welcome. Today we are joined by Dr. Aaron Opdyke, who will give a presentation on disasters, development, and engineering a sustainable future. He has been within the University of Sydney since 2018 and works as a lecturer for Humanitarian Engineering with a research and teaching focus on disaster discovery and sustainable development. He has received a Bachelor of Science in Civil Engineering with honors from California Polytechnic State University. He holds a certificate in college teaching, a Master of Science in Civil Engineering, and a PhD in Civil Engineering from the University of Colorado Boulder. For his work in the post-disaster shelter reconstruction from Typhoon Haiyan, he was awarded with a United States Agency for International Development Office of U.S. Foreign Disaster Assistance Humanitarian Shelter and Settlements Fellowship. So with that, I'll pass it over to you.
Thanks. Just 1 second and I'll get the slides pulled up on my end.
Yep, no problem.
Great. So I would just encourage everyone, as I'm going through today, if you do have questions, feel free to drop those in the chat, just so we can kind of keep track at the end of the session, and I'll try to answer those in a little bit more detail. So today I'm going to be talking about the intersection between disasters and the work that we do as engineers. Introducing this because it's likely something that maybe you haven't thought a lot about, and challenging maybe some of the ideas that you have. I think it's rather timely due to the events that we've had in Sydney. So the recent floods just a few weeks ago, and thinking about the role that we can contribute in addressing these problems. So I just wanted to start off by doing an acknowledgement of country. So again, today I am on the lands of the Gadigal people of the Eora Nation. And I'd just like to pay my respects to their elders past, present, and emerging. So before I really jump in today, I wanted to start off and contextualize this, really thinking about the Sustainable Development Goals. And so you may have heard of these. But these were a collection of goals that were adopted in 2015, and they were accepted universally by all countries. And they're really targets for us to think about ways to improve our quality of life. And so that's not just necessarily in lower income countries, but these are also goals that are applicable here in Australia. And so a lot of what we'll be talking about today is our role as engineers really in contributing to these. And so specifically, there's some that I'm going to be talking about that narrow in on disasters, which is where a lot of my work sits. But again, you may have heard or talked about these in your other classes as well. So specifically, some of the ones that we're going to be talking about today relate to the first goal, which is no poverty. There's a goal that's related to industry, innovation, and infrastructure. So ways in which we need to develop quality, reliable, and sustainable infrastructure globally. And then really the one that we're going to talk a lot about today and look at some current research that we're doing plugs into goal 11, which is focused specifically on reducing disaster losses globally. So looking at kind of what's going on globally. So again, disasters and some of the trends that we're seeing. So while the actual reduction in loss of life from disasters, so we're continuing to see that each year there's fewer people that are dying from disasters, the losses actually continue to increase. And so if we look at some of the, the current numbers, so on an annual basis, so there's over $520 billion in damage from disasters. And that drives an additional 26 million people into poverty. So this is really a significant problem. And a lot of the work that I'll be talking about today connects and ties into this as to how we can make contributions towards reducing these losses. I'm going to be talking today a lot about my research is focused in the Philippines. And so to kind of set the stage for what we're going to be focusing on today, and what happens often in low-income countries and just how devastating disasters can be, I thought it was useful just kind of starting off with this video. And so this is a storm surge from a typhoon, so that Sangeeta mentioned at the beginning, that I've done a lot of work studying in the Philippines, and this is not uncommon for really any typhoon that comes through there, and just how devastating it is. So again, if you think about that, and just kind of, I think it's a nice visual to kind of think about the issues that we're looking at trying to address. And so really, it almost looks like a tsunami, but that was just caused by sort of an average storm that came through and sort of the pressures that result in sea level coming up during that time. But I guess some of the questions and where I thought was useful is actually sort of grounding this in a very practical example. So a lot of my work, so before coming into academia, I worked for non-governmental organizations as well as for some government international assistance programs on disaster risk reduction. And I think there's a nice example, though, that sets the stage for today and what I'll be talking about a little bit further. And so I was actually, after this particular typhoon, so that storm surge event that we just looked at, in that particular typhoon, almost 7,000 people died in the Philippines. But I was actually at a reflection event that happened about 5 years after the fact. And so there's this man who was telling this story, talking about you know, what they did sort of in the preparation for the disaster, and they actually knew that this typhoon was coming, and they had actually evacuated into a local hotel, and so they felt that their house wasn't going to be safe, and so their entire family evacuated, and they were staying in this hotel. But during the typhoon, he was concerned about his belongings, and so actually he went back to watch his house while he left his children and his wife in the hotel. And you can see that storm surge is actually how most people died in this particular typhoon. And so, unfortunately, you know, he actually lost his entire family in that hotel. And so this raises questions about thinking about, well, how do people think about their safety in disasters? And what about our infrastructure can provide that safety? So again, this hotel was actually along a coastline. So there's a disconnect in, you know, what they were thinking was safe, and actually what resulted in deaths in this particular instance. So for example, the placement of the doors within this building, they actually opened out. And so what had happened actually is the water rushed in, it actually trapped all the families that were staying in the hotel. So again, something that we can do as engineers is thinking about, well, could we have designed those doors differently for evacuation purposes, or been more intentional about how we think about designing that infrastructure? So again, we're going to unpack sort of today and talk a little bit further about how people think about these hazards, and look at some research that we're doing from the Philippines more practically. But before I do that, I just want to get you thinking about this question. So, you know, we often hear the term in media, natural disasters. And so what I want to challenge you to think about is a disaster ever truly natural? So does a natural disaster ever happen? And so in order to answer this question, a lot of my research challenges this assumption. And rather than viewing them as events that we can't prevent, so we often talk about thinking about disaster risk through sort of a compilation of a few different components. And so the three main ones that we often talk about are the hazard. So for example, that could be the storm surge that we just saw. And those are naturally occurring events. So it's important for us to make the distinction between a natural hazard and a natural disaster. But really where my research is focused on is thinking about the vulnerability of both people as well as the infrastructure that we're designing. So, you know, when we talk about earthquakes, there's a sort of a term that gets thrown around a lot that, you know, earthquakes don't kill people, it's poorly built buildings that do. So it's often collapsed structures, it's where we decide to build our infrastructure that results in those losses. And so those are all decisions that we make, and often engineers are involved in making those decisions. And so we'll be talking about this complex interaction today between hazards, which again are just naturally occurring phenomena. So that could be an earthquake, it could be storm surge, it could be floods like we've experienced in Sydney, and the intersection between that and the vulnerability and exposure of our particular infrastructure that we design. And so I'm going to be talking just about one project, can kind of give you an example and a taste of what my research looks at. And really what my work is trying to focus on is not only looking at the scientific tools that we can use as engineers, but also trying to understand how can we leverage local perspectives or other ways of knowing, particularly in resource-constrained communities. So the vast majority of my work in humanitarian engineering, it really focuses on low and middle income countries where we don't necessarily have the same data or they don't have the same resources that we often have the luxury of working with here. And so this requires us as engineers to use different tools in order to understand and work in these contexts. And I'll be talking a little bit more about this. So for this particular research that I'm going to be talking about today, we actually were, again, sort of exploring that same region that I introduced, but we were interested in trying to understand, how do households, collective community assessments, and then more traditional scientific models, how do these compare both in estimating the hazard assessments that we do? So again, going back to the example that I started with today, maybe that household that had evacuated, they didn't realize that that was an area that was exposed to storm surge. But our scientific models actually were able to predict and tell that. And so on the one hand, maybe there's this disconnect between how people are understanding their hazards, but then more broadly also looking at trying to understand risk. And so really thinking about the intersection of the hazard component as well as that vulnerability that I talked about and introduced earlier. So for this, what I'll be going through today and talking a little bit about is a case study and a local government that we've been working with in the Philippines to try to understand these 3 different levels of assessments and how we might merge these to better understand disaster risk and also reduce losses. So specifically what I'm going to be talking about today is a project, and we've been working here for several years now. And so this is actually with a municipality. So this is an equivalent of a council in the Philippines that we've worked with and partnered with for this research, and working with their local office on disaster risk reduction. And so where this is at, so again, in Southeast Asia, so the Philippines is kind of right in the middle of that, and they're often exposed to a wide range of different natural hazards. And this particular research that we've been doing is focused kind of in that middle area. So you can see on the pinpoint on the left-hand side where this particular project is focused. So the first thing that we actually had to do, and just talking about some of the data limitations that we have, and I think this is interesting to contextualize it, is that we had to do a lot of work before we could even get to the point of trying to ask communities to assess whether or not they were exposed. And some of this was they just didn't even have basic information that was digital. And so a lot of what we had to do on the front end of this was actually trying to work with the local government there to do a lot of digital mapping. So for example, they didn't even have maps of where their buildings were, where their roads were. So they had hand-drawn or outdated maps. So a lot of the front end of this project actually involved a lot of that. And so these are some of the numbers that we had sort of behind that initial mapping, all using sort of open data tools. And so everything that we essentially have used for this project, it didn't cost the local government anything, just because in a lot of cases, again, they can't afford that expensive software that we often take for granted here. So we're using a tool for this called OpenStreetMap, which some of you may have used, and I think they use it in some of the transportation classes, or they may talk about it at least. So you can see kind of this was the before and after. So kind of going back, so this is what the map looked like essentially beforehand. So they had some basic roads, and we did a lot of effort sort of with working with communities to actually try to map all their buildings, all their infrastructure, so that we can understand and intersect that with trying to understand where those different hazards were. So you can see here, so this is an image of kind of what that looked like. So you can see that these are actually sort of all individual pieces of paper that we have laid out. And there's actually a QR code that's located on the bottom. And so what we could ask communities to do essentially was to map these. So, they could actually go out and they could fill in and hand draw their map of where they thought all the houses were. And then we could go back and digitize that information, look at that with satellite imagery that we had, and then actually sort of overlay and intersect those together. And then really kind of the next step in this was asking communities to identify what they thought about as their hazards. So again, this research, we were interested in trying to compare and look at, well, what did households think if we brought people together and we asked them to identify what are the areas in your community that flood? What are the areas that are exposed to storm surge? So what result does that come up with, and how might that be different than household? And then also comparing that with some of the more scientific models that we have about estimating these using different data. And I'll talk about some of the limitations of each of these kind of as we go and get into some of the results in just a second. But you may start out and you may have thought, well, what's wrong with probabilistic models? So as engineers, the models that we often use or develop, so hydrological models, for example, we don't often think about, well, how might those be wrong, or what might be missing from that data? And so that's really what we'll see in a second and highlight as some of the pros and cons of each of these. So what these community members are actually doing in this case, you can see is this is after we've mapped essentially all their buildings and infrastructure. And it's really simple. So we actually just slapped sort of a clear sheet on top of this, and they're actually sort of highlighting, and they're going to be drawing where they think the areas that are actually exposed to flooding are in their particular community. And so this was the output of what that looked like. And so really basic. So you can see, again, so they didn't have computers that we could do this on. So the local government had, one desktop computer where we could do this. So obviously we couldn't do this at the scale of, 55,000 people. So these maps were a really effective way to try to capture some of these local perspectives from the community mapping workshops. And so the NF, which it's kind of upside down on the diagram here, but you can see they were all sort of around this particular map drawing these. So those are the areas that they thought didn't flood. You can see the low areas that they've marked, some medium areas, and then high areas. And so those correspond to what we saw on the flood depths that I'll be talking about in a second, that compared to the probabilistic models that we were looking at. But it was a way for us to capture those local community perspectives. We then digitized this, and so giving an example of kind of what my own research and how I involve sort of honors thesis students. This was actually an honors project from last year, and so the students were digitizing those community maps, and so you can see that they've taken those. We've traced around kind of the outlines and overlaid that on top of all the buildings that we can see there. So that was part of what their research was looking at. I'll talk more about that maybe towards the end, or we can take some questions on that of what you might do for your thesis. And again, we did this for a bunch of different communities. And so this particular municipality, they had 49 of these smaller communities. And so the final output of this, you can see, is on the left side. And so this is what communities thought of their flooding. So you can see sort of the high areas, the low areas, and the medium areas, and those were defined based on flood depths again. So I'm just gonna kind of skip over that. But these are equivalent sort of depths that we're looking at between these two maps. And then you can see the more probabilistic model. So this is actually a 100-year flood map. So in other words, that's a 1% chance in any given year that this particular flood would happen. And you can see these are quite different. So what communities thought of it, you can see there's a lot of communities along the coastal areas where it's significantly higher than what we're seeing for these probabilistic models. So why is that the case? So some of the things that we saw and came out of this research that is quite interesting is actually some of the limitations in the data that we had for those scientific models. So they look much more precise, but actually once you dig into it and start comparing these, the area, for example, kind of on that right side, so that the coast is kind of on the northern side of these maps. It was actually missing, or it didn't have a lot of accuracy in the actual underlying elevation data to actually construct those models. And so what we were seeing is that the local perspectives were actually much better at trying to understand and capture those. But the thing that was missing in a lot of cases that we saw, so for example, for these flood maps, is that particular communities that weren't exposed as often, and maybe in narrower areas where they're not used to seeing sort of flooding occur, those probabilistic models did a much better job of trying to capture that. And so really for these rare events that we see that communities might not experience or think about on a daily basis, we really see that scientific models are doing a much better job of telling us about that risk and that exposure. Whereas kind of the daily basis, communities actually have a much better understanding of what's going on. We've also done this for some other hazards. So again, we weren't just looking at flooding. Today I'm just going to be talking about flooding and storm surge, but we've also done the same thing for this in looking at landslides hazards. And so these are actually the scientific models that we have for storm surge. And what was really interesting about this actually is when we asked communities to map and essentially see, where are the areas that are exposed to storm surge, a lot of communities couldn't even answer that question. And so we actually don't have any community maps from this. I'll be talking about in a second kind of the households that we actually were able to survey from this. But actually when we brought communities together, they said, we don't know. And part of that is just because it's a hazard they weren't used to seeing, or it was something that doesn't occur on a regular basis. So, it might only occur once every 50 years. And so they're just not used to seeing that hazard. And so again, this is where it's really useful for these scientific models to come in and then really provide us an understanding of, well, when it does happen, what's that risk going to look like? And so this was actually another honors thesis that I had last year. And so these risk models that we were producing out of this, you can see kind of the 4 different storm surge scenarios. So kind of moving from the top left down to the bottom right, you can see that. So that's a 1 to 2 meter surge height. So if the water comes up 1 to 2 meters, 2 to 3 meters on the top right, 3 to 4, and then 4 to 5. So these are sort of increasing storm surge events that we're seeing across these different models. And so again, this was a thesis topic. So the students, as part of this, were looking at trying to model and look at all the different building risks. So again, integrating that exposure, but then also looking at, well, what about the building is going to make it more or less at risk? So, you know, if it's made of concrete, for example, it's going to be at lower risk to storm surge than if it's just made out of, you know, timber, for example. And so what we saw from this, and kind of looking at some of the perspectives and risk, and particularly comparing this to when we asked households. So again, we actually couldn't come up with community maps, but a lot of household members actually in sort of stronger structures, or what they would think of as stronger. So, you know, they were made out of concrete, or they were more well built. They actually, in a lot of cases, weren't as aware of the risk to storm surge. And so for, you know, the households that were built just sort of haphazardly using scrap materials along the coastline, in a lot of cases, they're aware of that risk because they see that their house is not going to be able to withstand really anything. So, you know, they're more likely to actually evacuate to a safer area. But in a lot of cases, what we see is that households that are in more well-built structures, they often don't think about, or they're sort of unaware of those risks that they might be experiencing. So looking at kind of where those household perspectives for storm surge at least corresponded. So going back to, you know, the earlier example that I introduced at the beginning of today. So on the sort of moving from left to right, so again, the SSA 1, 2, 3, and 4. So each of these is sort of an increasing level of storm surge event. So it's higher inundation depth that we'd expect to see. And then on the right column that we're seeing, so both for the exposure and then also for the risk, we're looking at, well, what did households actually think? So the left one is just asking them, so did you think that it was, you know, your exposure was high, medium, or low? And then the risk, again, integrates all those building elements. So it's thinking about, you know, the construction type that they had. And so in a lot of cases, what we saw is that they were fairly well aligned sort of across this particular municipality in aligning with those lower level events. So they think about storm surge particularly sort of as, you know, I might be somewhat exposed to it, but a lot of households are not recognizing, we can see from that how deep that inundation is going to be. So in a lot of cases, they might see it as low, but they don't see it as necessarily affecting them to the extent that it might actually in these events. And then really, if we kind of look at the right diagram, so looking at the risk, what we see is that there's this big disconnect, again, for these larger events. And so that's, again, kind of going back to the point that I was talking about, is the scientific models can provide sort of a way of us enhancing community awareness for these particular risks that they might be experiencing. So again, taking this forward, so this is some of the more you know, theoretical work that we're doing to look at sort of estimating these risks. But on a very practical level, I thought it was useful to kind of cap out today's discussion and talking about, so what do we do with this information? So these are actually two of my honor students that I was working with from 2 years ago. So this is Ben and Luke. And so they were actually able to actually go over, as part of this work and this collaboration that we had, to do some work in assisting looking at increasing sort of the data that this particular municipality had. And so, like I mentioned, one of the big limitations that we've seen particularly is that even though we do have scientific models, in a lot of cases, the data that we have, it just isn't detailed enough. And so, you know, there's some basic tools that you might have learned. So for example, they're actually doing a survey of this and actually creating an elevation map that's much more detailed. So we can use some of those scientific and hydrological models to understand what areas are actually going to flood. So this work they were able to actually publish as part of their thesis, and this was some of the output from this. So ironically, this was the first sort of detailed survey that had ever been done in this municipality. And so this was the output from that. So you're looking kind of along the coastal areas, and so they've created this contour map. And then they were able to use this in combination with some of the hydrological data that we had to look at what areas were most exposed to flooding. And so they were also looking at some really basic measures. So things like, you know, how can we increase and look at what areas might need to be prioritized for drainage infrastructure. And so those black lines that you're seeing that are kind of dotted there are where they've mapped out existing drainage infrastructure is. And then these red areas are what areas are going to be exposed to flooding. And so we can see kind of where the current infrastructure is and then where they might need to look at expanding some of that drainage infrastructure. So that's kind of an overview of that work. Talking a little bit more broadly about what my research focuses on. So again, this is kind of just one example from today. So I do a lot of work looking at humanitarian response. So that's immediately after a disaster, and particularly looking at shelter and housing assistance. And so looking at that in a broad range, how do we build safer houses? How can we support households in their recovery when their house is destroyed after a disaster? Again, really with a focus on low and middle income countries. Disaster risk reduction. So that's some of the work that I was talking about today. So really thinking about, well, what can we do before a disaster strikes to better prepare? And how do we actually think about, defining, capturing that risk information for planning purposes? And then lastly, also looking at climate change adaptation. So some examples of projects that we've been doing in this area, also sort of domestically here in Australia, is working with Aboriginal communities and looking at, how can they adapt, for example, their housing for climate change impacts. So as it's going to get hotter, areas are going to be more exposed to climate change. What do we need to do to look at adapting to those particular needs? So I thought I'd keep it short, but I'm open to any questions, and we can talk and I can go back and kind of go through some of what we've covered today. So thanks again.
Yep. So thanks for that presentation, Aaron. We're going to move on to questions. So if you have any questions, please pop them in the chat or raise a hand using the raise hand button. I have a question here about what is the most challenging aspect of introducing new technology to the community during humanitarian programs?
Yeah, so I think if we think about technology and introducing new technologies to communities that might never have come across it before, in a lot of cases, it's about trying to understand what's socially acceptable or what are some of their needs. So giving a really good example of this from some of the work that we've been doing. So again, one of the things that we needed to do as part of this, obviously, was do things like household surveys and collect data. But we really needed to talk with households and talk with the community about some of their expectations about how that data was going to be used. And so in a lot of cases, these communities are really aware of the ways in which data has been extracted. And so that's one of the key concerns that we often need to have when we're thinking about introducing new technologies. But we also just need to be aware about other sort of constraints that those communities have. So, not just necessarily on how we collect data, but also on sort of new technologies that have been introduced. What are their priorities? And those are things that we need to think about and consider.
So going off of that, how did you become aware of what the community's beliefs and all that?
Yeah, so when we do this type of research, and really when we talk about doing any international work, I think it's really important that you have, and a lot of it's being driven by local partners. So an example that would be, for this particular project, we're working very closely with the local government. And so I think they're really kind of that crucial link into trying to understand all that history and complex relations of navigating sort of a different culture. And so I think that's really a vital element when we talk about trying to do really any of these types of projects internationally, is making sure that we have strong local partners to work with who can act as sort of that translation.
Yeah, that makes sense. Yeah. So what were the greatest changes that need to be made in engineering to ensure a sustainable future?
So that's a big question, I think. So I think this is obviously a lot of what we cover in our humanitarian engineering program and some of the classes here. I think one of the biggest ones that we often need to think more about as engineers is particularly the ways in which, when we talk about a sustainable future and what that means, is in what ways can we as engineers really contribute to social justice for communities. So and when I say that, thinking about the decisions that we make have a real impact on people's lives, and being more aware of how we as engineers are impacting those the benefit or the lack of benefit that communities have. So, I was talking last week, and I'm involved in another project. A great example of this is thinking about when we decide to build infrastructure as engineers, and thinking about how we include people in that decision-making process. So Redfern Station, which is just kind of down the road, and many of you may take sort of every morning. A lot of the platforms, for example, they don't have any accessible access, so that they're not accessible by a lift. And so in a lot of cases, people can't actually use those. And so, it affords this immense benefit for a lot of people. But again, at the beginning of that project, when Redfern Station was built, I know that was maybe 100 years ago, but there's been a lot of upgrades and opportunities since then. we often don't think about sort of making those decisions or consulting the right people. And so I think when we talk about sustainability and kind of, the future that we want to see to make it more equitable and just, I think we need to ensure that we're listening to communities, we're reaching out to people that are often disadvantaged, and trying to include them in the decision-making and design process.
Yeah, I totally agree. I think it's very important to make everything accessible to everyone and include what the community believes as well. What is the most memorable experience you've had from your line of work?
Yeah, so I think lots. I would say in general, I think one of the best things that I really love about the work I get to do is just interacting with so many different people from so many different backgrounds. So, getting to do international work, you get to meet some really fantastic people. And particularly I'd say, the community element of a lot of what I do is the ability to interact directly with communities. And so I think particularly a lot of places in Southeast Asia, which many of you have maybe traveled or you're even from, I think that they really just welcome you right into their home. And I think it's that side is really, I think, one of the best things that I love about my work is just learning about new cultures through it, and sort of interacting with people that are very different than myself.
Yeah, that's great. So I guess that leads on to what made you passionate about what you do. And could you tell us a bit more about why you chose to do research into it?
Sure. So I started out, actually, I had no intention of ever going into a research career. So I sort of was finishing up my undergraduate degree, and I had the opportunity to work in construction, actually. So on a few sort of major projects, and I think it gave me a lot of exposure to some really interesting technical elements. And so everything from working on bridge projects, so I worked on a rail project in Hawaii in the United States, and San Francisco on some large transportation infrastructure, in Los Angeles also on road infrastructure. And then I think through that experience though, I think what was missing, or kind of what drove me down this path, was again wanting to have more of that community engagement piece and kind of the everyday work that I'm doing. And again, as part of that, I was intending to do a master's degree, again in construction, and really no intention of going into a research career. But then pretty quickly sort of got wrapped up in it, and had the opportunity to do a PhD. And so that was really a research training experience, and that's really what a PhD is, if you're maybe thinking about that. But I think it was a great opportunity where I was able to do a lot of field work in the Philippines. So again, sort of that community engagement piece and trying to understand some of these complex issues that are going on. And then that sort of led me down the path that I'm on today. So like I said, and I've changed my mind, a dozen times. I think one of the pieces of advice that I'd give is it's fine, and it's going to be a messy career pathway for you, regardless if you want to go into research or into a professional career in practice. And so I think that's completely fine. And I'd say, even I'm sort of on a daily basis figuring out exactly what I'm doing or what I want to be working on.
Yeah. So going off of that, for engineers, undergraduates trying to put themselves out there, what would you recommend they do if they're unsure of if they really want to do the specific type of engineering or really any course?
Yeah, so I think my biggest piece of advice would be to say yes to do anything that interests you. So, take on as much as you can, as early as you can, to try to get that exposure. And so I think kind of reflecting on my own career path, I think that's what I did. And it gave me, you never really know, I think, what work's going to be like until you actually try it out. So if it sounds interesting to you, kind of passionately go after that. And if it doesn't work out, like I said, just pick things up, change the direction, and kind of go for other things. And so I think trying to sample and get an understanding of different options early on in your career can be really helpful to make sure that, later on you're actually deciding to go down the right path. So I think it's also, it's never going to be bad experience. So I think, like I said, any experience that you have, that diversity, I think, will be really valuable regardless of what you do and kind of where you end up further down the road.
Yeah. So what's the biggest challenge you faced in your career, and how did you overcome it?
Yeah, so challenges. So I think with this one, admittedly, I think that there's a lot of people that face more challenges in their career than me. I think the biggest thing I would say with this is, there's certain opportunities that maybe I really wanted to go after or I didn't get, and sort of that, made me sort of step back and think about where I wanted to end up and be. Yeah, like I said, I think I'm actually quite fortunate to say that, I haven't had a lot of actually obstacles in my career. I think that it's been more minor things. So like I said, I've gone down a path and then figured out that's not where I wanted to end up and be. So I think, those were barriers, but I think I've been quite fortunate. And like I said, I think as long as you accept even any failures that you have, and just kind of step back and move on, I think those are all valuable lessons.
You were saying how you struggled to identify your career path, or you had a bit of a wonky career path. Who did you turn to, and what type of resources did you look to figure it out?
Yeah, so I think the biggest thing with that is trying to find good mentors. And so I think, going to people and seeking out advice on, what a particular career path might look like. And like I said, I think people in industry are usually extremely generous with their time, particularly if you're a student, and trying to get you to understand, what that career is going to look like. So I think it's important early on in your career that you do try to find good mentors. And so whether that's somebody that's working in practice, academics, for example. And so I think one of the things that we always sort of lament as academics is that, people are always afraid to approach us sometimes. If they haven't interacted before, I think our doors are usually always open to come in. So, if you have a question about something, feel free to always knock on my door and just come talk to us about those. So, and, that stems from everything from just general questions you might have, or we can direct you to other people as well. Or things like reference letters. So again, I know that's something that eventually down the road you all need. So I think it is important, again, that you try to establish those relationships. I think it's important that you keep up with people as well as you progress in your career. So, keeping those mentor roles, maintaining relations as you're going, because you never know when those people are going to be important for a reference, or if you decide to shift directions or they pop up in another project. So I'm constantly finding that I'm stumbling back across other colleagues in sort of unexpected ways later in my career.
Yeah, I totally agree with that. I often get a little intimidated by academics, and I think, yeah, it's important to form a good relationship with them.
I promise we don't.
So for those people looking into going into academia, what's your advice for them?
Yeah, so I think, there's some great opportunities to test that out early. And so, like I said, kind of going back to the advice I was talking about, is try things out before you sort of, commit to it. We have a great winter and summer research internship program here, where you have the opportunity, and there's some scholarship money that's associated with that, or you can just do it on a voluntary basis, to work with an academic on a research project, just to try out, is it something that you're going to be interested in, and work on. Other universities also do as well, so now you can apply for those opportunities, or just approach an academic. And so, like I said, I think one of the main ways that you get to try this out is kind of through your honors thesis. And so I think that's a great test. If you like doing very independent work, or you find that you really are passionate about that, kind of the next step for you to think about in a research career would be looking at a PhD. So in a lot of cases, a PhD is sort of a prerequisite for a lot of research career pathways. But again, there's lots of different ways that you can approach that. So, my own work is very interdisciplinary. So it doesn't have to necessarily be, or it might be very different than what you think it is. So again, when you talk about PhDs, they're not the same as what your undergraduate coursework is. So you might take a few extra classes kind of at the post-grad level, but it's often sort of working one-on-one with a supervisor, independently developing your ideas. And so a PhD is kind of the next step in that process, and that kind of launches you off into a career where there's lots of options if you decide to go into academia. And so again, that's often a prerequisite, or other ways. So like I said, I think the numbers are, it's, probably 80% of people who get a PhD, they go work in practice. So there's lots of other research careers out there other than just working in academia.
What would you say the key skills are for people going into research?
So I think the big one, like I touched on, is that you really need to be comfortable independently thinking and developing your own ideas. And really being curious, I would say, is so it's maybe not so much a skill, but it's just something that you always have to sort of be interested in trying to learn. So I think on a daily basis that I'm really fortunate. And like I said, the ability, particularly on academic research or research in general, is in a lot of cases that you have so much flexibility to look at, whatever you want and really think about big picture problems that we're experiencing. So on a daily basis, I get to decide really what I want to look at. And all the friends that I have, they're working in practice at the moment. That's not necessarily the case. So there's always somebody else that's telling them what to do, or it's being driven by financial decisions. And not say that my work doesn't also sort of require some of those boundaries, but you do have a lot of ability to sort of reflect and work on what you want to actually focus on. I think that that's a really valuable aspect of deciding to go into a research career.
I never really thought about that, how like when you go into research, you're the one doing it, and you don't have to, you have more freedom than someone who's working like under a big company or something. So a question was asked, how can a civil engineer contribute to the UN goals for sustainability?
Yeah, so what I started off talking about, and there's different ways. So, you might be doing, or a lot of the work that I do is much more explicit in contributing to those goals. So it's something that we are often thinking about on a daily basis, or using those goals as ways to identify the research that we then sort of end up doing. But, you don't necessarily have to be thinking about that on a daily basis to be contributing to those. So, maybe you're looking at trying to reduce emissions and the carbon footprint of buildings. So, that's contributing, for example, to goal number 11 in that. And so a lot of organizations are now thinking about this, and some of the big engineering firms are incorporating this more essentially into the work they're doing. So I know, for example, Arup, I think recently has redeveloped kind of their entire business strategy actually around the Sustainable Development Goals, in thinking about trying to use those as a way to drive their work. And so I think particularly over the coming years, we're going to see more and more of that coming in more explicitly to the work that you might be doing if you go out and even just work for a more traditional firm. And like I said, one of the really key important aspects of those goals is that they're applicable everywhere. So, Australia has targets that we're trying to meet under those goals. And so I think it's important that we're thinking about those, and they provide a way to think about development more broadly, if we think about that globally in ways in which, we can also make progress to that. So we often think about them just in the context of low-income countries, but that's not really what they're intended for, is that we can also be making progress towards development. And like I mentioned, so we have our own gaps here. So whether that's disability inclusion in the infrastructure we're designing, or a variety of other ways.
Yeah. Do you think the future of engineering is going to more a sustainable approach, and why do you think that is?
I think it definitely is. I think some of it is being driven by awareness. So I think we're becoming, or you might be hearing more about sustainability in the classes you're taking. What that means, trying to reduce the resources that we're using them more efficiently. Like I said, I think kind of going back to maybe one of the other questions earlier, is that I think we've gotten really good as engineers about thinking about the technical aspects of sustainability. But I think the area that we can try to think more about is social sustainability. So for example, the communities that we're working with and for, is the infrastructure we're designing, does it meet their needs? And again, that's not always a technical answer. Sometimes it's a social one. And so it's thinking and ensuring that we're considering that when we're designing infrastructure.
Yeah. So you were talking about different types of sustainability. What types are there, and could you give like an explanation for those types?
Sure. So we often talk about sort of 3 different pillars of sustainability. So we talk about social sustainability. So, that could be community acceptance of projects, for example, or whether or not it's actually meeting sort of social needs. Economic sustainability. So is it financially viable? So if we think about, ways that we can reduce cost, that's another one. And then the third one, which is probably what people are more familiar with, would be environmental sustainability. So, how do we reduce our environmental impact? And so it's important that we're thinking about all 3 of those when we talk about sustainability. So again, it's not just focused on the environmental aspects, but also thinking about the financial implications, and also thinking about the social implications of what we're designing.
Yeah, I normally think of the environmental side when I think of sustainability. I don't normally think of social sustainability, but yeah, it's quite opened up my mind to economic and social sustainability. So how do you think the industry has adapted to COVID and in terms of sustainability?
So I think, you know, for the most part, from what I've seen, is a lot of organizations and companies have continued sort of with the progress they were making before. I think there's been a lot of discussion, and maybe you've even been thinking about your own sustainability and kind of the actions that you're taking during COVID. You know, I think one of the biggest ones that sort of everyone's been impacted by has been travel. So, you know, we're traveling less, which is having lower emissions potentially. In my own work, for example, you know, I'm doing less international travel. We're thinking about ways in which we can reduce that. So working with local partners, for example, to try to do more of that work. So those are some of the ways in which I think we're seeing, or people are being maybe more reflective of sustainability practices. And my hope is that, you know, we think about carrying forward some of that into the future. I'm sure we'd all like to get back to in-person meetings. I certainly would. And so I think that, you know, we don't want to lose sight of that value as well. And that's really, I think, about sustainability. When we talk about it, it's about a balance between those two. So, you know, there are, and that's why I think that social piece is so important. You know, it's not necessarily just being driven by environmental impact. You know, at some level, we also need to make a balance when we talk about those trade-offs.
Yeah, hopefully we could do an in-person academic seminar soon, but yeah, it's been COVID and everything. We couldn't really do it, but hopefully in the future we get more in-person things going on. With that being said, if there's any last-minute questions, or if you have anything more to add, we might just close up.
No, I think that was it on my end. So like I said, if there's any other questions, you can drop them in the chat, or otherwise I'm happy to wrap things up for today.
Yep. I don't think there seems to be anything in the chat. So yeah, thank you so much for your presentation. And on behalf of everyone watching, I learned quite a lot, and I appreciate you taking your time out of your busy schedule for this. So for everyone who is doing this for PEP hours and watching the academic seminars, the next academic seminar is on the 19th of May, and we have Industry Night next Friday. So the tickets are sold out, but I think there's 3 giveaway tickets. So look out for those. They'll be on Facebook. But with that, I think we're done with the Zoom.
Perfect. Thanks, everyone.